Hello and welcome to this quick tutorial explaining how to use the Carbon Crease node. We have a basic simulation of a square grid mesh which just falls onto a collider. If I press simulate, not much happens, it just falls down and stays there. Alright, let's create a Carbon Crease node. Our crease node can be found on the shelf right here, or alternatively in the Carbon menu item, under Create Utils, and here it says Crease. Alright, let's create a crease, and we have the UI here, and we can add a crease because we have one crease. Well, which mesh do we want the crease on? Our basic mesh, so not the output, but the input mesh. Perfect, our start mesh called mesh shape. Now, let's have a look at the mesh. I'm going to hide the physics draw of the carbon simulation, hide the cloth output mesh, and show the start mesh. There we go. Our mesh already has a nice crease line baked into the geometry, so we can have a nice crisp crease. I'm going to right click on the mesh, keep holding right mouse button and go to edge. Now I'm going to select the first edge, hold shift and keep selecting edges until I am all the way through. Alright, now I can apply these edges onto the Carbon Crease node. I hold Control and keep pressing Control on my keyboard. Now I select Carbon Crease Shape 1 and I can let go of Control now. Here in the edge group, where it says apply selection, I can click to bring up the dropdown. I go to replace the currently empty selection with my selected edges. There we go. And we immediately see we also have a guide geometry physics draw here. This shows which edges are being used for this crease. In the parameters here, we can change the line width depending on your scene scale. It might be larger or smaller. Let's go back to 4. Also has a tick box to draw names, which will draw this font, which describes the name of the current crease. The name can be found here for each crease. The name is a combination of the node name, Carbon Crease Shape 1, plus the index into the crease array of this crease node. Next up, we find ourselves with this parameter called angle. Angle is the angle you want to use on your crease. So per default, it is 0, which means flat. And there are 3 options how to apply an angle. An angle can be applied as a replace, so it will replace all of the reference angles, or it will add to it, or blend. If you go blend, you will see a blend parameter of 0 to 1, which allows you to blend between the reference angles and your angle specified on the crease node. I'm going to go back to replace, because that's what I want to do. But what am I exactly replacing? Well, we're replacing the crease information, so the angle information on this line. This is the reference metrics, the reference angles that we are replacing. So if you go back to our cloth, what is the reference? We currently don't have a reference mesh specified. We only have a start mesh. If this is the case, the new start mesh will be used to create the reference metrics and angles for your carbon cloth. So our start mesh is mesh shape. You go to mesh shape, is a flat mesh. So actually our angles are already 0. If you're on the crease and we replace 0 with 0, nothing will happen. So you probably want to set a value greater than 0 to actually see something. Okay, I'm going to set it to 90. Also, I will hide the crease shape or its parent transform so I do not see this physics draw. If you want to keep it, you just bring it back. Also, you can change the color of it. Right now it is selected, so the highlight color is red. But if I unselect it, you should see this orange color, which represents this one color. I can click on it and I can change it, for example, to blue. If I blue, done. Nothing changed because I still have my node selected. It's not selected anymore, so it's not highlighted in red, and we see the color that I specified, which is blue. All right, anyways, I do not want to see it, so I'm going to hide it. All right, so we have our angle set to 90, we have our group. What's left to do? Well, we need to go on the mesh, and we can actually tell it now to use that crease node, which is here in the reference section called creases. In the drop-down, select your Carbon Crease Shape node. All right, and we're good to go. Let's hide the mesh and show the physics draw of the carbon simulation. Reset, maybe press Ctrl S to save our scene, and let's press play. Nothing happens. So why does nothing happen? It is because we actually have A, low conversions, only 10 iterations, 10 subdivisions, and B, our cloth is set to a bend stiffness of 0.1, which is quite weak, so allowing the cloth to be quite flexible, like a cotton, for example, and not very stiff like a leather. So if I was to change this, for example, to 100 and increase the convergence by changing subdivisions to 100, reset the simulation and run this again, there we see a crease appearing. It's not perfectly 90 degrees because it's probably still not converging fully. But now what have we done? A, we made the whole simulation converge more, and we made it slower by going to 100 subdivisions. And B, we set the bend stiffness of the whole cloth. So now the whole cloth is very stiff, which we might not really want to do. We want to affect the crease separately from everything else. We do not want to set the whole cloth very stiff just so we can have one crease. So I'm going to go back to 0.1, the default value, go back to the simulation, set it to 10. So we're back to where we started. If I now go to frame 1, reset the simulation, and press play again, nothing happens. So how can we now make the crease appear without affecting the whole cloth? Well, that's what the strength parameter is here for on the Carbon Crease node. Let's set this to 100, and this applies a strength only on this specific crease and nothing else. Let's reset the simulation and press play. And here we go, that just popped up really strong, bringing our crease in. All right, so maybe 100 was too much. Let's go down to 10. Let's reset the simulation again and press play. And there we go. It's a bit weaker now. All right, let's try 50. There we go. That looks pretty nice. That's a nice balance. All right. So what if we invert the crease? Minus 90, because creases are signed. So you can bend up and you can bend down. Reset the simulation and press play. There we go. Now the crease goes in the other direction. So if you wanted to have a very sharp, let's say, fold over, you might think, well, let's go ahead, here, and set it to 180. But now there's a problem. If you set it to 180, you're really trying to force perfectly fold over each other, and you're going to get popping because your crease is going to fight the cloth colliding with itself. What you actually want to do is either decrease the strength to allow the crease to fail and the collision to prevail, or you decrease the angles. Instead of 180, you might want to say 170, which will allow some space for the cloth to resolve its collision without being ugly. And there we go, we got a very steady state simulation. It is not popping here anymore. Obviously, there's quite the strong effect in the beginning, so you might want to So you might want to actually increase the lead duration from 0 to, let's say, 1 to bring, and maybe stasis mode, to bring it very slowly into effect. So I'm going to press play now. There we go. We have a much smoother result because we allowed the simulation to slowly converge to the state where our angle of 170 is applied instead of applying it abruptly on the first frame. So lead simulation is always a good thing to use when you have a reference that is different from the start mesh. Remember, our start mesh is angle 0, but the reference we overrode with 170 on this crease. I hope this makes sense, and I hope you have fun using this node. Thank you very much for watching.